She said she's having issue on chemical changes. That's it. So we are going to check it very soon, maybe in the next two class. The next class will be checking the theoretical aspect of acid and base within 30 minutes. Then we will go to redox reaction. So today we'll be checking solubility, and within 5 minutes, I'll just explain environmental pollution. Not a major topic in your chemistry, so I won't be dwelling on it. But we'll be checking solubility today, and it's a very important aspect in your chemistry. So let's proceed. How many of us are in the group? Okay, Titi, you're back. All right. So the chemical changes we will do it in the next two class by God's grace. So we are going to solubility today, and we'll be checking the solubility curve. We'll be checking some calculations and the theoretical aspect of solubility also. So solubility is the maximum amount of solute that can dissolve or that can be dissolved in a given amount of solvent at a specific or particular temperature. That's what solubility is. It is a maximum amount of a solid that's so that can dissolve in a given amount of solvent. We have to restart the clock. This thing is drug of solvent at a specific temperature. So give me 1 minute. At most, I need to sort out this system. Yeah, okay, sorry for that. Okay, so we are talking on solubility. So let me share my screen again. Okay, so like I said, we are checking solubility today, and we'll be talking about three basic components: the solvent, the solute, and the solution. So we said solubility is the maximum amount of a solute that can be dissolved in a given amount of a solvent at a particular temperature. That is what solubility is. So like I said, we have a solution, we have a solvent, and we have a solute. I believe you are familiar with the solution is talking about the mixture, the overall mixture. We call it the homogeneous mixture. That is when you mix the solvent and the solute together. What you have is a solution. So solution talks about the homogeneous mixture. And the solvent talks about the substance that dissolved the solids, like water. The substance that dissolves the solids. I saw your linear. Solute is a substance dissolved by the solvent. Okay? I think I'm joking. Substance dissolved by the solvent. So we have different solvents, different sorts, different solutes. We have different sorts, and we have different solvent also. Um, Water is a major solvent, the universal solvent that we have that can dissolve virtually all substances. So before we move into the calculation, let's go to types of solution. Types of solution. So we have the unsaturated solution, unsaturated solution. So when you hear the word unsaturated, it simply means it contains less solutes than the maximum possible solute that it can have. That is, the solute is lesser than than what it should have, or let's say is lesser than the appropriate solvent that can dissolve the solute. They get it now. For example, let's say you want to take your Gary and you now put a lot of water and you add half cup of Gary inside the water. That is unsaturated. It simply means that particular amount of water you put inside your cup requires some amount of Gary to be dissolved in it. So when you take a very low or lesser solute, we call it unsaturated solution. So it is a scenario that contains less solute. Contains less solute. Less solute than maximum possible. That is from the normal solute that should be dissolved in that solvent. It simply means it can dissolve more solute, right? So unsaturated solution can dissolve more solute. Please, they can ask you what type of solution can dissolve more solute. So it is unsaturated solution, right? The saturated solution. It contains maximum solute at given temperature. That is the specific required amount of the solute that is essential for the dissolve. It is what the solution contains. It contains the maximum solute, like the appropriate solute that is needed to be dissolved in that solvent. It simply means no more solute is needed. Did you get it? It has contained the maximum solute already. So no more solute is needed to be dissolved. Please, do you get it? In case they ask you, what type of solution needs no more solute? It is not supersaturated, though. It is, although supersaturated also does not actually need no more solute. But when we say a solution contains maximum solute, we are talking about saturated solution. So the last one is supersaturated. Supersaturated solution. Supersaturated solution contains more solute than expected or than normal. Contain more solute than normal. Do you get it now? So the actual number of salt that is essential to be dissolved in that solvent is too much. So it contains more solute than normal. Hope that is taken. So let's quickly go to solubility curve, which is, have you written that one down? Can I move on? Gives, are you done? Titi? Okay. So let's move to solubility curve. Solubility curve is just showing how solubility changes with temperature. So sometimes they can ask you question. They can give you a graph and ask you to interpret it, and they will give you different options. Or sometimes they can ask you to just predict the gram or the temperature that the solute is dissolving. If it is the gram, they will tell you how many gram of solute is being dissolved using the solubility curve above. Oh. So in solubility curve, the y-axis is your solubility, while your x-axis is the temperature. The y-axis is what? I believe you still remember what y-axis is. Y-axis is your vertical axis, yeah? So x-axis is your temperature. Let me look for a diagram. Coming. I want to look for a solubility curve. Okay. I'm coming up. If you have a solubility curve diagram, you can help us to one. Okay, I've seen one. So look at it. So look at the solubility curve, everybody. Like I said, you can see um that your x-axis, which is this axis here, at the down part here, it contains your temperature. The temperature increases from the left to the right, from 0 to 20, 20 to 40, with a consistent figure, isn't it? And your y-axis, which is your vertical axis, contains the gram, the mass in gram, that is dissolved in 100 gram of the solvent. Now, how do you read the solubility curve? Let's start with the curve A. You can see this curve A, it looks like a light blue curve, Abi. Look at it. You can see that as it started around, this will be mass of about, let's say 4 or 6. The solubility firstly increased gradually at first, but when it reached here around temperature of 40, this should be 50 or 48, you can see the solubility increased more rapidly at that temperature. So from 45 degrees C or 48 degrees C above, the solubility increased more rapidly at a very high temperature. So it simply means this type of salt solubility is actually dependent on temperature. As the temperature increases, the solubility increases. As the temperature decreases, the solubility decreases. Do you get the explanation for that A curve? Look at the big curve. That's dark red. This one here. Can you see it? Look at the temperature and the solubility. The solubility started from 0, and actually it increases a little bit. So it simply means temperature actually has little effect on the solubility of that salt B. Please, are we together? You can see that all throughout the journey, the solubility uh, did not go above the 20 gram the mass for this that will be dissolved in the solvent. You can see that. So it shows that there's a slight increase in solubility, but temperature does not have much effect on that curve, on that salt. This is article. And if you look at the third one, which is the C, can you see here? It's also started around maybe 4 or 6 mass. You can see it has a very sharp increase. We call it steep increase. Immediately as the temperature is increased, the solubility increase very sharp, isn't it? So it simply means at low temperature, there is no solubility, and at high temperature, there's always a very high solubility. Please, exactly. Look at the D. The D also has something similar to the B. It started around 30 degree or 32 degree. at 32 gram. Look at it. It almost have this steady increase and almost like a flat line. So the temperature has little effect. So that's a mid effect of temperature. And the E also has a steep increase, just like the C also. So you can see it started from about 50 gram. The solubility started from 50 gram and it increased. So at a higher temperature, the solubility continues to increase and up. So I will give you a question that how do you know which is saturated? For this type of solubility curve, what is actually showing is showing the effect of temperature on the solubility. You can see as the temperature is being increased, the solubility also is increasing. And it's not actually denoting which one is highly saturated or which one is undersaturated and all like that. But let me look for a graph that shows that saturation level. Okay, as I look for that, let's quickly move to factors affecting solubility. Then we will start with some questions where we check the graph and the theoretical questions together. So factors affecting solubility. We have the temperature. The first one is the temperature. So for the temperature, for the solid particles, solubility increases with temperature. But for the gases, the solubility will decrease with temperature. For the solid particles, the solubility increases with temperature. And for the gases, so just pay attention to these factors. They can ask you how temperature affects solubility. They can tell you there is a substance and they give you the state of that substance to the gas. They can just write hydrogen gas plus O2 and giving H2O. And they ask you if the temperature is increased, what will happen to the solubility of that gas, or if the temperature is decreased. So as you can see, solubility decrease with temperature. If you see soft drinks, some soft drinks, if you put it inside the freezer, they have more gases than warm drinks because solubility decrease with temperature, like I said. So some soft drinks they lose gas quickly than the chilled one. So that's just the concept there. Another one is the nature of solute and solvents. The nature of solutes and solvents. So this one talks about like the solvent likes. like dissolve like. So there's a particular solvent that can dissolve a particular solute, and there are particular solutes that can be dissolved by a particular solvent. For example, sugar and water, grease and petrol, paint and temperature, and turpentine, sorry, and all like that. So this one talks about like substance dissolving like substance. The another one is prayer, and this is applicable to gas alone, any substance in question. So increased pressure will increase gas solubility. Increased pressure will increase gas solubility. So these are the three major things: the temperature. Solubility increases with temperature for solids, and solubility decreases with temperature for gases. The nature of solute and solvent, like we said, like dissolve like. There are some solvents that can only be dissolved by a particular, there are some solvents that can only dissolve some particular solutes, and there are some solutes that can only be dissolved by a particular solvent. And the last one is pressure. So, pressure sets increase in pressure will lead to increase in gas solubility. So let's look at some questions, one or two, and I will give you some examples to do, some classwork to do. So let's go to some solubility calculation. So they can ask you to calculate some things. Solubility. The question says if solubility of sodium chloride NaCl is 36 gram per 100 gram. Let's start with the cheapest. Per 100 gram water. Says comma, how much dissolves in 50 gram of water. There are some questions that we have to predict if it is a saturated solution, an unsaturated solution, and supersaturated solution based on your calculations and also based on the graph. We'll still get there. Let's just take it little by little. Look at the question here. The question says if solubility of sodium chloride is 36 gram per 100 gram water. So now said how much of NaCl will dissolve in 50 gram of water. You get now. So it simply means the solvent 100 gram of water, which is our solvent, dissolve 36 gram of NaCl, isn't it? So then I say how much salt will dissolve in 50 gram of water. That means 50 gram of water will dissolve. You first multiply. So that will give us 50 times 36 divided by 100. Are we together? So, what is 50 times 36? I'm not with my calculator. So 50 divided by 100 is 2. That's 2 divided by 36. That's 18 gram. It simply means in NaCl will be dissolved in 50 grams of water. That's the implication of that. 18 grams of NaCl will be dissolved in 50 grams of water. So it simply means that the solubility is actually directly proportional to the amount of water. That means half the water is equal to half the solute. And if you double the water, you have to double the solute. That's clear, right? So let's move to a slightly advanced question on solubility. I believe that is clear for everyone. Ah, yes, I know the jam. Yeah. Sorry, I want to plug my system. Give me just 5 seconds. So I believe that is clear. Let's take this question. If the solubility of potassium nitrate can't breathe. Echo. Let me write out the question. If the solubility of potassium nitrate is 110 grams per 100 gram water at 60 degrees C. The question says, how much will be solved in 250 grams of water? It's shaking. If- Hello, can you guys hear me? Sorry, I lost my network. So look at the question. Solubility of potassium nitrate is 110 grams per 100 grams of water. So it simply means potassium nitrate is being dissolved in one being dissolved. He just studied computer engineering for nothing. This guy, I beg. Sorry, guys. I'm sorry for that. So there's a guy here that just studied. He's a graduate too. Just studied computer engineering for nothing. I'm not on thing. All right. So sorry for that, guys. I'm struggling with my network. Okay, I said it's actually the same thing to the one we did just now. They said if the solubility of potassium nitrate is 110 gram per 100 gram of water, it simply means 100 gram of water is dissolving. So it's actually the same thing. I was actually thinking it's quite more complex. So if 100 gram of water dissolve, 100 gram of water dissolve 110 gram of potassium nitrate, it simply means okay, 250 gram of water 250 gram of water will dissolve what? That's equals multiply, right? That will be 250 gram of water multiplied by 110. Everything divided by 100, isn't it? Then you get your answer, isn't it? These are all together. So this is just the logic. Make sure everything that has the same unit is on one side. You know, they said 100 gram of water dissolved 110 gram of potassium nitrate. And they said we should find the gram of potassium nitrate that will be dissolved in 250 gram of water. So that's the reason why I first wrote 100 gram of water, because we know the 250 gram of water that will be dissolved, that potassium nitrate. These are all together. So that's why we said 100 gram of water dissolve 110 gram, and 250 gram of water will dissolve 250 gram times 110 divided by 100 gram per water. Please, do we get it? Please, let's look to, I want to look for more technical questions. I'm coming up. Okay, this is still fair. Let's see. It's actually a dumb question, but I think it's actually simple. Let me just copy it. So look at the question here. They said a solution contains 72 gram of potassium chloride dissolved in 200 gram of water. They now said, given that the solubility of KCl is 36 gram per 100 gram of water, determine whether the solution is unsaturated, saturated, or supersaturated. Do you get the question? So now, if you want to solve this, you don't get the question. Give this. Can you see my board? Ah, Jesus, Jesus. I'm so sorry. I forgot I had to reshare. I'm so sorry for that. Can you guys see my board now? I'm so sorry, please. I actually forgot that I didn't reshare again. So the last question, I hope you understand that one. They said we should find how much potassium nitrate that will be dissolved in 250 grams of water. So they gave us 110 grams of potassium nitrate that was dissolved in 100 grams of water. They now ask us to know to calculate the mass of potassium nitrate that will be dissolved in 250 grams of water. So, like I said, the logic is that make sure the same unit is on one side. Since they give us 250 grams of water. So what we are looking for is the mass of sodium nitrate that will be dissolved in this 250 grams of water, right? So therefore, what you should write first is what you have as your question. So since we have 100 grams of water, 100 grams of water dissolving 110 grams, therefore 250 grams of water, you can see that these two, they are on the same side. Do you get the logic? So the next thing you do is to just cross multiply. So this 250 will go and meet 110. This 100 will come here. So the answer will be 250 times 110 divided by 100. And that will give you your answer. I believe that is taken, right? So to the second question, which seems more trickish, is actually a jam question also. They said a solution contains 72 grams of potassium chloride dissolved in 200 grams of water. Given that the solubility of potassium chloride is 36 grams per 100 gram water, determine whether the solution is unsaturated, saturated, and supersaturated. So they want us to know if this uh if this is saturated, unsaturated, or supersaturated. So the first thing we need to do, okay, TT said saturated, that's fast. So the first thing we need to do here is to find the expected solubility for 200 grams of water. Now, they gave us 72 grams to be okay. Now we can use this one to calculate it. For example, let me use the first case that we can use to get the answer. Here, they said they have given that the solubility of KCl is 36 grams per water. So which simply means 100 grams of water, 100 gram water will dissolve 36 grams of KCl, isn't it? So what will 200 grams of water dissolve? 200 grams of water will dissolve 200. Like I said, you cross multiply, multiply by 36, everything divided by 100. So 100 divided by 200 is 2. 2 times 36 is 72 grams. Daniel, there's no fuel in this thing. So it's 72 grams. Please, are you with me? Sorry for that interruption. So it simply means 72 grams. Okay, they now say the solution contains 72 grams of KCl. Yeah. Can you see? And we got 72 grams here also. So it simply means the actual is 72 grams. Assuming this is why question, but jam don't need your. There's no mark for steppings. And the expected that we just calculated is also no, the expected is 72 grams. The actual is also 72 grams. So it simply means they are equal, right? So since they are equal, that means they are saturated. So TT is right. So do you get how it is done now? I think it is simple, Ivy. All right. So let me see if you guys can do this. Let me copy a question for you. The solubility of Pity you dey para today. Oh. It's like you had your favorite food this morning. You didn't eat your favorite food. Oh, you're not eating. You've not eaten at all. Okay, you like solubility. That's good. You're expecting 3 questions in your 50 questions or 40 questions in your exam. So others, I'm waiting on. Others you are waiting on. Do you want me to do it for you? Others will Biko. Saturated. What's your why do you say saturated? The gifts. Oh, how far? Okay, because of our time, let me quickly do it because we have a lot to do. Look at the question. The question said the solubility um, of a salt at a certain temperature is 40 gram per 100 gram of water. They now said if 120 gram of the salt is added to the 200 gram, what type of solution is formed? So, like I said, you can use this. We want to calculate the mass, the actual, and the expected mass. So we know if it is too much, then we can say that it is supersaturated. If it is the same thing, we can say, oh, you say saturated. Okay, let's check. Now, follow me. Now, looking at this, they said we have 100 gram of water. To dissolve how many gram? 40 gram, right? So that means 200 gram of water will dissolve how many gram? That will be 200 times 40 now, divided by 100, isn't it? Are we together? So 100 divided by 200, that's 2. 2 times 40 is 80. That means we have 80 gram. Abi, and they said here that we have 120 gram. That if 120 gram of salt is added to 200 gram of water, and on a norms, what should be added? It should be 80. It simply means they've added extra 40. And let me do it like this. Extra 40 gram, Abi. So what type of saturation is that? Is that not super saturated? Because 120 gram that they added is actually greater than the 80 gram that we get now. So that makes it super saturated. Please, are we getting it? Gift. Gift, do you get it? So it is actually simple. So the first thing you just need to, you will use your solvent to calculate the mass that it should dissolve. So once the mass they give you, the theoretical mass, is bigger than your calculated mass, it simply means it is supersaturated. But once your given mass, theoretical mass, is lesser than your calculated mass, it simply means it is unsaturated. And if they are the same, simply means they are saturated. Please, do you get the logic? All right. So I think that's fine. What else can we do? Let me see if I can see. Okay, there's a question here again. I think it's synonymous. Yeah, let's do this. Titi, don't say the answer. Let's others talk. They said a solution contains 90 gram of salt of a salt in 100 gram of water at a temperature, at a particular temperature, where the solubility is 70 gram per 100 gram of water. So they want us to know if it is saturated or undersaturated or supersaturated. Gifts call. Who else did they call? Let me check. Confidence, Lillian. A Paul said supersaturated. Gift, Lillian. Confidence. Coffee, coffee. Alpha. So Paul said supersaturated. Gift, what about you? Unsaturated. Mm. Linear alpha. Lillian alpha. Is actually direct. Now look at it. They said a solution contains 90 gram of a salt in 100 gram of water. The gram they gave us at solubility is the same thing as the gram of water that they gave us at the present. They said a solution contains at the present, it contains 90 gram of the salt in 100 gram of the water, 100 gram of water. Where this and the solubility of that salt is 70 gram per 100 gram of water. Now look at the present is 90 gram. The solubility ought to be 70 gram. Normally, the solubility should not take more than 70 mass on in 800 gram of water. So it simply means the solubility is lesser than the mass of the salt at the present. Please, are we together? The present mass of the salt is 90 grams, isn't it? We don't need to calculate anything because look at the mass of the the volume of the solvent of the solubility. What is the volume? It's not 100 grams of water. At the present, it's also 100 grams of water. So that means we don't need calculation. Are we together? It's just normal common sense. Please, are you with me, guys? Now look at it now. They said 90 grams of salt in 100 grams of water. That's what it has. They now said where the solubility. Look at that. Said where the solubility is 70 grams per 100 grams of water. It simply means the solubility of that salt should not contain more than 70 grams. This 70 grams at 100 grams of water. Now look at it now. They said at the present now, the solution contains 90 grams at 100 grams of water. It simply means we've added 20 grams to the salt, which make it super saturated, right? These are all together. Gift, are you getting it? Like Gift is not getting it. You know, anytime you see solubility is the preference. Like what you are referring to is the exact thing the solution should contain. Like if they tell you that, look at the previous question that we did. They said the solubility of a salt at a certain temperature is 40 grams per 100 grams of water. It simply means the standard is 100 grams of water should dissolve 40 grams. Anywhere you see solubility, it talks about the standard. Do you get it, Gift? Do you get confidence? So that means the first thing you will write down is your standard. So 100 grams of water should dissolve 40 grams of salt. Now, they gave us 120 grams of salt that is dissolved in 200 grams of water. It simply means 200 grams multiplied by 40 divided by 100. So we have 80. And the actual should be what? The actual should be 40. Isn't it? So if the actual should be 40, you can see, and we got, no, sorry, the actual, we got 80. Is it 80 that we got? Yeah, we got 80 grams of salt the last time. And the actual there, the one they gave us later is 120. Like the present gram of the salt. So look at 80 compared to 120. You can see 80 is lesser than 120. Therefore, it is supersaturated because they've added more salt. They ought not to add more than 80 grams. But, but they've added 40 already, making 120. That's why we have 120 grams. Look at this same question also. They said a solution contains 90 grams of a salt in 100 grams of water at the temperature where the solubility is 70 grams per 100 grams. The solubility is 100 grams of water should dissolve 70 grams. Now, they now said the same 100 grams of water is now dissolving 90 grams. That's supersaturated. Please, do you get it? Gifts, do you get it? Let me try and look for, give me a few minutes. Let me look for another question so that before I leave here. I'm coming. I'm trying to look for a question. Okay. I've seen a question here. They said, is that not question 4 or something? Is that the solubility? So after this, I want us to move further more because we have a lot of things to do. Of NO3, sodium nitrate is 92 gram per 100 gram of water at 60 degrees C. They now said a student dissolves 184 gram of NaNO3 in 200 grams of water at 60 degrees C. So they asked us to check the solubility. Can you do it, guys? Gift, do you understand it? Can you do it yourself? No answer. I will come and kidnap you now. Gift, I'm waiting for you. Linear, confidence. Do you get the question? That the solubility of sodium nitrate is 92 gram per 100 gram of water. It simply means 100 gram of water can dissolve 92 gram. Paul, you are raising your hand. You two don't answer. Gifts, Lillian, and confidence, supersaturated. Okay. Gift alpha. This thing should not stress your gift. It's like you are missing something. Yeah, the answer is saturated. This thing is stressing your gift. Why is it stressing you? Hmm? Did I take you out for an ice cream hangout? You like ice cream? Lillian, where do you make mistake? Look at the question. It said the solubility of sodium nitrate is 92 gram per 100 gram of water. It simply means 100 gram of water should be able to dissolve 92 gram, Abby. No, this is the standard. You use the standard to calculate your experiment. That's what I told you. They now gave us 200 gram of water. So that would be 200 gram of water should be able to dissolve, because multiply. That's 200 multiplied by 92 divided by 100. Isn't it? 100 divided by 200 is 2. 2 times 92 is 184. That's 184 gram. Isn't it? So that's 184 gram. So that means the actual gram that should be dissolved in 200 gram of water should not be more than 184 gram. And they said the student dissolved 184 gram. Simply means it is saturated. Yeah, please don't make error. So 184 gram is your actual, and your expected is also 184. So that means it is saturated solution. Do you guys want us to do another one more question, or you are okay? We should continue with solubility. Hmm? Are you guys okay? You guys should talk now. We should move on, Abby. Okay. So let's move to what's the next topic? Cost solution. So we said solutions are homogeneous solutions. They are homogeneous mixture. So four solutions are heterogeneous mixtures that look like a solution. Do you get it now? What do I say? Four solutions are heterogeneous mixtures that look like solutions. So we have different type of force solution. The first one is suspension. I will give you a table very soon after this note. That table, I want you to read it and calm it, because everything Jam will be asking under force solution is in that table. What are the properties uh of suspensions? Number one, large particles. The particles settles on standing and can be filtered. Large particles can be filtered. Particles settle on standing. Examples are the muddy water, and the water-based paint. I will still give you a table too. Another example of suspension is colloids. The colloids. The properties include they are medium-sized particles. They do not settle. They show Tinder effect. Please pay attention to this aspect. So, I'm telling you, after your jump results, all of you have to send in your jump score. If you don't send me your jump score, it simply means it is well. Especially Paul, Titi, Gifts, Linear, all of you. Hi, Gaba. I will enter your DM one by one. Send me your jump score. If you don't send it, once you don't reply immediately, I know something don't solve. And the Lord is your strength too. So examples of this is the milk, fog, is the heart. They can say milk is an example of what? Fog is an example of what? Aerosol sprays. So let me look for the table. We have emotion paint also here. Like fire, like rain, let your glory fall. Like fire, like rain. I saw this at my school, and it's a very wonderful thing. Please, they ask this thing a lot. It's just a summary of everything I. Where should I put it? So please write it down. It explains the property. You can short it. Should I short it for you? I know some of you will not short. The first one talks about the particle size. The solution is a homogeneous mixture of two or more substances. They say less than 10 to 9 meter or one micrometer. So that one is between 1 to 1,000. The last one is greater than 1,000 nanometer. Sorry, this one is greater than nanometer. This one is 1 to 1,000 nanometer. This one is 1 nanometer. So which one is very small? So two solution has a very small particle size. Yeah, you can just write it in terms of size. So which one is larger? Suspension is larger. It has a size greater than 1,000 nanometer, and the medium one is colloidal. So instead of you writing all these notes, you can just write. That's one way to make it easier for you. This one for the two solutions, just write very small, right? For the colloidal, just write medium. This one write large. Do you get it? So the visibility, they said the solute particles are visible to the naked eye. So the solute particles is invisible to the naked eye. That one, there's nothing you can do. There's no way you can shorten that. The next one is the Tyndall effect. They said does not show, it shows, may or may not show. There's nothing you can do about it. The banner movement doesn't show banner movement, it shows may or may not show. Some special may or may not show Tyndall effect, and may or may not shows banner movement also. There's another one, the filtration. They did not have the filtration here. Filtration for the two solution, it is no. For the colloid, it is also no. For the suspension, yes. And for the appearance, they can ask for appearance also. Solution is always clear. These other two are always cloudy. Cloudy. Which other ones? I think that's all. So I think we are done. And in case they ask you, crystals forms on cooling for the supersaturated solution. They form on cooling. Are you guys done writing? If are you done writing? So you guys should go and read environmental pollution yourself. You don't have time. They may ask one question from this aspect, or they may not ask any question. I don't want us to dwell on topics that doesn't matter. So after the class, go and read types of environmental pollution, sources, effects, and how to control it. So they can ask one question from this. It's actually also a biological, theoretical. You can use your normal knowledge to answer that. Hi guys, not writing. Okay. Lillian, are you done? Confidence, are you done? Confidence, are you done? Titi, I believe we are done now. Hello, guys. Okay. So please go and read this after the class. Environmental pollution. Read the types, the sources, the effects, the control measures. Just glance through it. I don't want that to waste our time. I would have asked us to quickly through it. Okay, the types of environmental pollution includes physical, mechanical, biological, geological, chemical, destructive, and the likes. These are the types. And environmental pollution is just the introduction of harmful substances into the environment. So pollutants, in case they ask what are pollutants, they are substances that causes pollution. You get it now? So the major three types of environmental pollution is air, water, and soil. So when you get to air pollution, is when gases is affecting the environment or they are in excess amounts that are harmful. So harmful gases being released into the environment is air pollution. For example, carbon monoxide. Those black thing that always come out of car exhaust pipe, and also incomplete combustion. Sulfur oxide also, nitrogen oxide also, hydrogen sulfide, and dust and smoke. The examples of air pollution, we call them pollutants, air pollutants. And effects of air pollution, they causes respiratory disease. They can cause acidic rain when there is too much of some harmful gases in the ozone layer. They can cause acidic rain. They can cause global warming, and they can deplete the ozone layer. They can reduce visibility and all. So how can you control it? You can use clean energy, regular vehicle servicing, tree planting, and all. Water pollution, blah 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 blah. Let's move to redox reaction. We have lesson. I'll just do a little introduction to this, and we'll continue in the next class. And I'll give you some questions on the previous topic that we treat just now. So when we talk about redox reaction, we are talking about two type of reaction: oxidation and reduction. So the OX here stand for oxidation, while the R here stand for reduction. So it simply means in some substances, as oxidation is going on, reduction also is going on immediately. So there's a way you can explain oxidation and reduction. We have in terms of electron loss, we have in terms of oxygen loss, and we have in terms of hydrogen loss. So those are the three ways we can explain oxidation and reduction. So let's start with in terms of electron. So when we talk about reduction is gain of electron. While oxidation is loss of electron. So there's an application they gave us when we were in secondary school then, and it is oily rig. So once you remember this, it simply means oxidation is loss of electron, while reduction is gain of electron. Do you get the logic? And do you understand when we say something lost electron? If something lost electron, what will happen? It will become positive charge, Abi. Isn't it, Lillian? And if something gives an electron, it will become negatively charged, right? Lillian, or what is on law? You don't sleep, Abi. Lillian, are you sleeping? Why not answering me? Let's say, for example, let's say A plus B gives A plus B, and this one becomes minus, this one becomes plus. And they ask us to tell us which one is an oxidizing species, which one undergoes oxidation, which one undergoes reduction. You can see that this A from 0 is has lost an electron. It lost one electron to become positive charge, isn't it? It simply means A here has lost electron. Gift, do you get it? This A, what did I say? It has undergo oxidation. Why? Because it has lost one electron. Gifts, do you get that? So when we say oxidation, simply means an element has lost an electron. It can be 1, it can be 2, it can be 3. Look at this B. This B has become negatively charged. It simply means it has gained an electron. Since it is just negative charge, it simply means it has gained one electron. Assuming it is -2, it means that it has gained 2 electrons. You get it now? So from here to here, this is reduction. Isn't it? And you can see it simply means it has gained an electron. So that is in terms of electron transfer. So in terms of addition of oxygen, let me just do this for you so that you can get it in full. Oxidation. So oxidation, in terms of addition of oxygen, it is addition of oxygen. In terms of hydrogen, it is removal of hydrogen. In terms of electron, it is loss of electrons. You get it? And in terms of oxidation number, it is increase in oxidation number. So reduction, it is loss of oxygen or removal of oxygen. addition of hydrogen. Gain of electron. And decrease in oxidation number. So we'll be checking many examples on this in the next class. But let me just give you one. Let's say, don't let me balance it. Let's say Mg plus O2. What will it give us? That should be Mg O2, right? Oh, that should be MgO. So if we put two air, we put two air. Now, if they ask you, you can see magnesium here. Do you see that there's no oxygen here? Are we together? And for magnesium, it became magnesium oxide. Here. That means oxygen has been added, I think. So it simply means magnesium is oxidized here. These are just elementary oxidation and reduction. You can see magnesium has been oxidized here. Why? Because oxygen has been added to magnesium to give magnesium oxide. So that is what oxidation simply means. So also, we have reduction. As oxidation occurs alone, reduction can occur alone. But when the two is occurring together, that is when we have redox reaction. Somebody should give me the reaction for this. If copper oxide combined with hydrogen, what would be the product? Anybody?
To give copper and water.
What is a pop?
To give copper and water.
So that's copper plus water. Is it balanced? It's balanced, I mean. So you can see here, copper has oxygen here, right? Okay. And it has become copper here. So it simply means copper is it oxidized or reduced? Copper oxide here. Is it oxidized or reduced?
Oxidizing agent.
I'm talking about is it reduced or oxidized? I'm not talking about agents now. Don't let us mix it together.
Is reduced.
Don't mix oxidized agents. You want to confuse your friend. Copper oxide is reduced. Yeah, you can see. So hydrogen also has gained oxygen. Hydrogen is oxidized. So next class we'll be talking about how oxidation and reduction occur together. And from there, after that, we'll be talking about reducing agents and oxidizing agents occurring together. And that is your redox reaction. Right. Let me see if I can see a few questions on solubility. Or we should just continue on oxidation and reduction. Did we check past questions on solubility, so we should continue on oxidation and reduction in the next 10 minutes? Which one do you guys want?
So let's do questions on solubility.
Okay. Give me some minutes then. Gives anyone. Your mouth like anyone. I'm done. Five, five, 5 minutes. Five. Eh? Okay. Sorry, guys. I have a disturbance here later. All right, so the guy is disturbing me. That's how Gibbs also disturbs me. Uh, so the critical. Okay. Solubility is best defined as the A amount of solute that dissolves at any temperature. B, the maximum amount of solute that dissolves in a solvent at a given temperature. C, the volume of a solvent that is required to dissolve a solute. D, the rate at which a solute dissolves by a given solvent. Anybody? D, the maximum amount of solute that dissolve in a solvent at a given temperature. Yeah, very good. A solution that can still dissolve more solute at a given temperature is said to be A, saturated. A solution that can still dissolve more solute at a given temperature is said to be A, saturated, B, supersaturated, C, unsaturated, D, dilute. C, unsaturated. Very good. Which of the following best describe a saturated solution? A, contain excess solute. They said which of the following best describes a saturated solution? A, contains excess solute. B, contains no solute. C, contains maximum solute at that temperature. D, they forms crystals on heating. C, contain maximum solute at that temperature. Very good. From a solubility curve, crystals are formed when a solution is dashed. I told you, from a solubility curve, crystals are formed when a solution is dashed. A, heated. B, filtered. C, cooled. D, diluted. Heated, okay. From a solubility curve, crystals are formed when a solution is heated, filtered, cooled, diluted. Crystals are formed when a solution is cooled. It occurs in supersaturated solution when there is excess solute. All that is taken. Right. Look for more questions. The solubility of most solid substances. The solubility of most solid substances in water. A, decreases with increase in temperature. They said the solubility of most solid substances in water. A, decreases with increase in temperature, is unaffected by temperature, increases with increase in temperature, decrease with pressure. It is said A, decreases with increase in temperature, they increases with increase in temperature. The solubility, I said, as you increase the temperature, the solubility of solid substances increase. But for gas, it decrease. Please, Titi mark back there. Which solvent is best for removing grease stains from clothes? I think I gave you now. Like the solvent, like. I think I gave you like 4 or 2. Which solvent is best for removing grease stains from clothes? A. Water. B. Ethanol. C. Kerosene. D. Dilute acid. All of you on the fear, right? You don't reach your side. Izzy said kerosene. Izzy said ethanol. Titi said kerosene. Lillian said ethanol. Then which solvent is best for removing grease stain? It is kerosene. No, kerosene can dissolve non-polar substance. And I think grease is a non-polar substance. It is kerosene. Which of the following is an example of suspension? I think I gave you some example of suspension. A. Meat. B. Fog. C. Muddy water. D. Salt solution. Muddy water. Yeah, that's the first thing I gave to you. No, it's muddy water. All those mink fudge, they are not for suspension. They are for colloids. When I say suspension, I have large particles that settle on standing. And that's what muddy water does. Colloidal solutions are characterized by, listen to this carefully. I know you guys have not read it, but I don't know if you can still get it. Colloidal solutions are characterized by A. Large particles that settle easily. B. Very small particles that pass through filters. C. Particle that shows Tyndall effect. D. Particles visible to the naked eye. Particles that shows Tyndall effect. Very good. Clap for yourself, everybody. I said clap for yourself. Oh. All right, that's fine. Let's look for 1 or 2 questions more. Which of the following is a true solution? True solution. A. Starch in water. B. Mud in water. C. Sugar in water. D. Paint in water. Sugar in water. A. Sugar in water for Gift. Lillian. That's good. Which statement correctly compares? He said, which of the following is a true solution? Starch in water, mud in water, sugar in water, paint in water. Not a solution like this up like now. It is sugar in water because sugar dissolves completely to form an homogeneous solution. Which statement correctly compares two solutions and colloids? Which statement correctly compares two solutions and colloids? A. Both can be filtered. A. Both can be filtered. B. Colloids are homogeneous. B. Colloids are homogeneous. C. Two solutions do not scatter light. Two solutions do not scatter light. D. Colloids have small particle than true solution. This question is kind of technical. Izzy said A, Gift said C, Paul said C. Linear, where is linear? Where's linear? Linear, what's your answer? Yeah, the answer is C. Hey, yeah. I said, which statement correctly compares two solutions and colloids? But I like how they put it. They said both can be filtered. Both cannot be filtered. Colloids are homogeneous. Colloids are not homogeneous. Two solutions do not scatter light. What they mean there is that two solutions do not show Tyndall effect, but they use scatter light because they want to scatter your brain. They are using scatter, scatter, scatter. Don't mind them. So do not scatter light simply means they do not show the Tyndall effect. All that is taken in case of another time. And the colored have small particles than two solutions. That is not right. So the answer is two solutions do not show the Tyndall. Two solutions do not scatter light, or two solutions do not show the Tyndall effect. I hope that is taking everyone. So the calculation aspects, we've done a lot of calculation during the class for those that joined early. What will I say? Please do well to practice more calculations. Insolubility, they may ask 2-3 questions. That they ask you calculation, or they ask you differences between all these 4 solutions. Maybe colloids, or the other guy, suspension or something. So just pay attention to those aspects. And they will ask you 1 or 2 questions. That one you cannot miss it. They ask 1 or 2 questions. They can ask you to predict, is it undersaturated, is it saturated, is it oversaturated? Or they ask you theoretical questions like application, just like what we just did now. That's it. So I'll be releasing the notes after the class to your group. So for those that joined late, you can go through the notes. But I'm not sure if you will get to the notes. But if you go and watch the video, you will definitely get it. However, I will still drop the notes for you guys. So you are about 19 days closer to your 19 days now to your exam. I hope you guys are preparing well. Please do not give up. It is getting closer than you expect and than before. If possible, reduce your sleeping hour, reduce your playing hour, reduce your chatting hour. Focus on your exam for now. After your exam, you have enough time to sleep. You have enough time to rest. You have enough time to chat. Then you can say, I want to do video call with you. I will do video call with you. Don't worry. Only if you pass your exam. If you don't pass your exam, you self, you not enjoy your video call. You just be causing people that do not offend you. So I don't want you to be hurting people around you because you didn't do well in your exam. I wish you success in your exam, sir. And we are rooting for you. So till Friday, there will be a meeting in chemistry. I want you guys to go ahead and read the environmental pollution. Read it again. They may not ask you question on this, but however, still read it. Just within 15-20 minutes, should be done with everything on environmental pollution. So fulfill all righteousness by reading it. And do especially gifts. Gifts, if possible, go and do like 2-3 more questions on your what's it called? The topic we just treated now, so that you can get more familiar with it. I think that's all. Next week Friday, I'm not sure. May I not be available. I have something so important to do. So it's possibly we meet on Sunday and we'll not be available on Thursday, Friday, and Saturday. But I only have a class with you on Friday, so by Sunday, I will know how to schedule my class on Friday, sir. If possible, we can do the class on Wednesday. So we'll be having 2 sessions on Wednesday. If you guys permit, one in the afternoon, one in the night, so that it will cover for Friday. Not this Friday, I mean next week. Yeah. So you guys do have to take care of yourself and enjoy yourself. But fine. Yeah. Bye bye.